Hello, we're going to do another number of the day. This is the third one. Number of the day 3 and 48. So go ahead and find all the factors of 48. So how do you know if you found all the factors of a number? Make a factor T-chart. So make a factor T-chart on your paper and do the factors of 48, please. All right, one thing about finding the factors of a number is when you do a factor T-chart, you want to make sure you have evidence of why a factor is or isn't a factor. So for example, if you look at my factor T-chart, I have evidence. I put a kind of imaginary division sign to do 48 divided by 1 and reminding us that you do for factoring, it's kind of like division. So 48 divided by 2 is 24. Then when I got to 48 divided by 3, I was unsure. I just didn't know. So I had to check. I was like, is 3 a factor of 48? So I did my division. I did 48 divided by 3. And lo and behold, 16 is a factor. So the factor pair of 3 and 16 equals 48. So you do not want to automatically think that 3 is not a factor just because 48 is a large number. 3 is actual a factor. So then you have your 4 times 12, 6 times 8, 8 times 6. 5 is not a factor. What's your evidence? You don't have a 0 or a 5 in the ones place. 7 is not a factor. What's your evidence? 7 times 7 is 49. So you always want to have some type of evidence of why something is or is not a factor. All right, now I'm going to talk about the factor trees or the factorizations. So all I did was I took the factor pairs and I made them, I started trees with the factor pairs. The only factor pair I did not use is the 1 times 48. So I'm going to go ahead and list these factorizations because these are, even though they're only factor pairs, these are two factorizations. They are factorizations of 48. All right, so let's move on and let's go ahead and do our factorizations and complete those. Remember, if it's a prime number, you leave it alone. So go ahead and pause it and try to come up with the other factorizations of these trees. Okay, so I went ahead and finished the factor trees for all 4 of the trees. So starting with the 2 times 24, 2 was prime already, so I left that alone, but I had to break down 24. Then I had to break down 12. Then I had to break down 6. And then finally I got to all prime numbers. Then with the 6 times 8, I had to break down both the 6 and the 8 because neither 6 or 8 are prime numbers. So then I got 2 times 3 times 2 times 4. So then I had to break down the 4. Over here, 3 is already prime, but I had to break down the 16. Then I had to break down the 8. Then I had to break down the 4. Over here, I had to break down both the 4 and the 12 because both of these 4 and 12 are composites. So 4 breaks down to 2 times 2. 12 breaks down to 2 times 6. Then I had to break down the 6. This is 2 times 3. So here goes some other factorizations or factor strings. You can call them factor strings or factorizations. So another one, it will be 2 times 2. 2 times 2 times 12. 2 times 12. That should equal 48. Another one would be 2 times 2 times 6. That should equal 48. Another one would be 2 times 2 times 2 times 2 times 3, which is the prime factorization. That's the prime factorization because that factorization has all prime numbers. All right, here goes another factorization, 3 times 2 times 8. Do I have that anywhere? Nope. So 2 times 3 times 8. Here's another one, 3 times 2 times 2 times 4. So we have 2 times 2 times 3 times 4. And then 3 times 2 times 2 times 2. So we already have that one. That one is the prime factorization. All right, let's look at this one. 2 times 2 times 2 times 6. We have that already. 2 times 2 times 2 times 3. That's the prime factorization. We have that already. Let's look at this one. 2 times 3 times 2 times 4, which is 2 times 2 times 4 times 3 times 4, which is that one. 2 times 2 times 3 times, yep, and then that's the prime factorization. So here are some factor strings that equal 48. And then this one in black is the prime factorization. So is 48 prime or composite? It is a composite number. We obviously have more than 2 factors. Is 48 even or odd? Is it an even number? Is it a squared number? Nope. None of these factor pairs are the same number. You have a 6 times 8 and an 8 times 6. So that's not a square. And then let's do our multiples. Let's start with the first multiple of 48 is 48. So go ahead and do the first 10 multiples of 48. All right, so the multiple monster. Remember, the monster gets, the multiples get bigger, bigger, and bigger, and bigger. So your multiples are over here. I kind of wrote big, but I did the first 10 multiples. I knew when I got to 10 because I got to 480. The number is 48. Put my my 0 there. So I know 48 times 10 is 480. So these are the multiples of 40, the first 10 multiples of 48.